So far we have 53 students. Okay, it's good enough. Okay, before I continue to the next topic, it's about the exponent and log. Before that, I will share with you. I will show you how to answer this question. Okay, this is question number 40. You can refer this question from our exercise from your UKM folio. There's question number 40, exercise for topic 1, linear and quadratic. Okay, if please during the lecture, if you have any question, just open your mic and just switch on your mic and you just ask your question. Otherwise, please mute your mic. So in order to make sure that our recording is there is no interruption in our recording. Okay. So let's look into this question number 40, topic 1, exercise topic 1. Based on the following demand and supply function, P equal to 174 minus 6Q, and P equal to Q squared plus 14. There are two equations here, demand and supply. A, find the equilibrium price and quantity. And then sketch in a diagram the demand and supply functions and then show the price and quantity at the equilibrium level. So the first question is about what is the equilibrium level. Equilibrium price is PE. Equilibrium price is PE, and then also we need to know what is QE, the quantity, the equilibrium quantity, the amount, the quantity at the equilibrium level. Okay. So what is equilibrium? How to find the equilibrium point? At the equilibrium point, demand equal to supply. Demand equal to supply. What is demand? Demand is represented by demand equation, whereas supply is represented by supply function. So if given in the equation, P equal to 174 minus Q, 6Q is a demand, D, because the slope is negative. And then the next one, P, D is for S, supply function. Since there are only two equations here, in the question, two equation given in the two function given in the question. So one of them are demand and one and the rest is for supply. So in order to find the equilibrium quantity, equilibrium price, we just to equalize, or we just to put the D equal to S. What is D? D is 174 minus 6Q equal to S. S is Q squared plus 40. Q is quantity, what we call it, demand function is linear, but the supply is quadratic. So now we have two type of equation here, linear and quadratic. So now at the equilibrium level, D equal to S. Now we can solve. We can from this equation we can arrange the equations like this. So I can we arrange the equations. So negative QA minus 6Q plus 174 minus 40 equal to 0. Equal to 0. So this equation can be simplified. Negative QA minus 6Q 174 minus 40 116 equal to 0. So now we need to find, you must we need to find what is Q to make the equation equal to 0. What is the number? What is quantity? Q is quantity. So this is for quadratic, as I said earlier. If you want to find to calculate the value of Q that make the equation equal to 0, we need to use the quadratic formula. negative b plus minus b squared minus 4ac. Sum all of them are square root of sum all of them and 2a. Okay, based on this equation, we know a equal to -1, a equal to -1, and then we have b equal to -6, and c is equal to 160. Okay, that is for uh for uh for quadratic formula. So now we just replace and put a, b, and c. So negative b is -6. So -6, negative -6 plus minus -6 squared minus 4a, a equal to -1, c equal to 160, square root of all of them, and 2 times -1. So this is equal to, I hope you can calculate this. Use your calculator. Again, I keep reminding you all. Make sure you have the each student must have their own scientific calculator. You need this calculator during the ujian, during the test, during the final exam, and then please bring your stationery, your calculator for test and for final exam. Make sure you have you are ready with your calculator, scientific calculator. Okay, now this is 6 plus minus square root of, I hope you can calculate, uh, this square root plus minus 26 divided by -2. So there are two numbers here. The first one is 6 minus 26 divided by -2. Now we have -20 divided by -2. This is equal to +10. Is equal to +10. And then the second one, 6 plus 26 divided by -2 equal to 32 divided by -2. This is equal to 16. There's two value here. These two value, because now we are talking about the demand and supply. This value is belong to Q. This maybe I can write here. This is for Q1. This is for Q2. Or because the question is about the equilibrium quantity. Okay, let's say Q1 and Q2. Q1 is positive, Q2 is negative. Okay. In economic, quantity must be negative. So it must be positive. 0 and positive for Q. Q must be positive. Q never negative. So there are two answers here, one positive, one negative. So the correct answer is QE equal to 10. The negative value of Q2, -60, we cannot take this as a equilibrium quantity because the value is negative. We just ignore. You need to calculate. You need to find this both value, both two value, but the right value, the right answer is just when Q is positive. The other Qs, when the Q is not positive, of course, it is negative. You just write in bracket, just ignore. So the correct answer is Q equal to 10. Okay, that's for QE. So this the equilibrium quantity. Equilibrium quantity. So what is PE? Equilibrium price. Price at the equilibrium level. PE, we just just replace, just substitute QE equal to 10 into demand or supply equation. Okay, you need to just to choose one of the equation. Let's say I choose a demand. Because the demand is linear, we can calculate it easily. So PE equal to 174 minus 6 times 10. Okay, 174 minus minus 6 times 6 times 10 is 16. Now we have 114. Okay, 114 is the PE, the equilibrium quantity. Now the equilibrium price. The equilibrium quantity is 10. The equilibrium price is equal to 100 and 140. Okay. Any questions so far? Is everything okay? Can you all follow me?
Yes, no doubt, doctor.
Yeah, thank you. I need actually I need your response. At least I know my class everything is okay. There's no disruption in terms of internet or Microsoft Team. Okay. That's how to answer the question. I hope you can focus. You can apply this concept, linear, quadratic, and so on. To find the correct answer. Okay, B, 40B. Sketch in a diagram the demand and supply function. Show the price and uh, quantity at the equilibrium level. Okay, now I will show you how to sketch the graph. We have two equations here. P, let's say I again, P equal to what is P? 174 minus 6Q. And then we have another P is for the supply equal to Q squared minus 40. Squared minus 40. Okay. So now we need to draw this line. Okay, for example, let's say how to draw the line. I will show you how to draw. I will show. Okay, let's say this is our uh, uh, x-axis. Uh, Now we have another. Okay. Now this is for uh, Q for quantity. This is for this. Sorry, this is for P. Okay. Now we have. Now I would like to draw the first the demand function. Since there's the demand function. This is a demand function, linear, and then the supply function is quadratic. So since the demand function linear, it's very easy to draw the line. So we just need to know the intercept and the slope. Okay, let's say the intercept this one 174, and then we have negative c. The slope is negative. So since p, please remember p must be positive, q also must be positive. So we can draw the line for demand just like this. Okay, let's say for example this for 29. Okay, let's say for example. Okay, there is for uh wait, okay. Wait, yeah, I will show you how to draw this line clearly. Okay, so for demand, which okay, this is for demand. The right one is for demand. This is P equal to 174 minus 6Q. Okay, the second one is about quadratic. Okay, how to draw the quadratic graph. I hope you can refer back to my note how to draw the graph. But I will show you in this case the graph is the quadratic is p equal to 6 square minus 40. Okay, this intercept. The intercept is 40. We just plot the 40. They say this is a 40. Now we just draw the graph like this. This is, okay, I will draw again. Okay, just this 40. This is for demand function. P equal to q squared minus 40. Since the A is equal to 1, positive, the graph is open upward, like you. The graph is open upward. Then make sure we just draw the graph at the area P positive and Q positive. Okay, this is the equilibrium price and quantity. QE is equal to Q equal to 10. And PE is equal to 100 and 140. And that's how to find to calculate the uh, the graph for this function. Okay, I hope you can follow me. If you have any question, you can ask me anytime. Okay, that's all about our example. Any questions so far before I proceed to our lecture?
No, doctor.
Okay, thank you. This my your lecture. I will continue on topics 1C to part 5, exponential and log. Okay. Okay. That before this, I have before this, we are learn about linear equation y equal to mx plus c, and the second one is about quadratic ax squared plus bx plus c. Today I will explain about the exponential function. What is exponential function? In general, we can write the function can be written as equation 1.19. That is y equal to b to the power of x. Y of x equal to b to the power of uh, x, where b is a base of the exponent. We also know b is a base for exponent, and and uh, and b must be positive. It's greater than 0. B cannot 0, and the value of b is also must not equal 1. There's if b equal to 1, the y is always equal to 1, because any 1 to the power of any number is also equal to 1. That's why for exponent, b must positive, greater than 0. B cannot be 0. If b equal to 0, then b 0 to the power of 1 is also equal to also equal to uh, 0, and b must not equal to 1, positive, greater than 0, and it's not equal to 1, and the exponent x, the exponent x is real number. X can take any number, next from negative infinity until positive infinity. And then, in other words, equation 1.19 is also called as exponential function with base 1. Base 1. So the reason why b must be positive and cannot equal to 1 is that if b equal to 1, we have fx is also equal to 1 for all x, and then this also called as a constant function. But when b is equal to 0, then fx will equal to 0 to the power of x will be undefined for negative value of x. Okay, that's the basic concept of the basic the general concept of linear function. Okay, but b okay, b must be positive. Okay, for example, there are few examples here for linear function. There's an example for exponential, y equal to 2 to the power of x, and y also can also equal to we can replace x equal to 0, x equal to -1 into the equation. That is for exponent. So again, what is exponent? Exponent is when we have equation like this: y equal to b to the power of x, b with x power, the exponent power of x. That is for exponent. So there are some rule of exponent here. If you refer to section 1.8.2, actually there are a few rules here. 5, 6, 7, 8 rule here. I not I will not ask you to memorize all these things, but very importantly you understand what this this table is very important. When you learn about the exponent, you must know how to modify, how to find the value when the function is exponent. Okay, but sometimes, especially in in the next topic, you might need to use this concept of exponent from rule number 1 until rule number 8. Okay, but in class I will share with you from time to time in a specific example how to solve this, how to use exponent or log when you try to find the equilibrium quantity, for example. I will show you later. Okay, that's okay for the graph of exponential. Okay, for the graph of exponential, there are some property here. Okay, I will explain to you about this property of the graph for the graph for the exponential function. Okay, the properties of the exponential function can be listed as follow. There are few characteristics for exponent. The first one is about the domain. The domain is the value of x in the exponential function. Okay. If you refer this page, I think it's page number 41. Number 41. Okay. The first one is about the domain. Okay, what is domain? Domain is x. Let's say y equal to b to the power of x. What is it? Domain is for x. The domain of any exponential function is the domain, in other words, can take any value, real number or any value. In other words, the x can take the value from negative infinity until positive infinity. X can take any number, rational number, and so on, from negative infinity until positive infinity. That is for exponential function. The domain. This about the domain of the exponential function. What does it mean? Okay, if you refer to this graph, for example, okay, when we draw the graph, let's say this one, y equal to bx. I would like to draw this graph. For example, when we draw this graph, make sure that the graph is from negative infinity of x until positive infinity of x. In other words, the graph is the value of x can be negative infinity or positive, or positive infinity, or positive infinity. So x can take any value. So the graph, when we draw the graph for exponent, make sure the graph is above the y-axis. Oh, sorry, x-axis. That's what does it mean by the domain, the value of x. But for the y, the value of y, the value of or the range of exponential function always zero or at least zero and above. So in other words, the value of the function, the value of y must be positive. Y cannot be negative. In exponential function case. Okay, that's the range is equal to y. The range is equal to the value, to the y value. This y value, the value of the function must between 0 and negative, 0 and positive infinity. For example, this value for y. Any above x-axis, show meaning that the value of y is positive. So the graph can cross any value, can have any value of y, as long as the y is positive. Y must be positive. We cannot draw this is area, there's the quadrant both x and y positive. This is x negative, y positive. The below one is about x negative, y negative, and also the right y-axis. This quadrant is belong to x and also p, whereas p is positive, y is negative. So that's about the basic concept of exponential. Okay, what else? Okay, the graph of fx equal to bx has y-intercept. In other words, the graph cross the y-intercept when y equal to 1. When the value of y equal to the value of y equal to 1. That's the graph for exponential function. When we draw the graph, if we refer this page, okay, the graph must cross at point y equal to 1. Y equal to 1. And then the basic concept. If we have the different type of exponential, you might draw the wrong answer, just to make sure that how to find the correct position. We just set when x equal to 0. Since y equal to bx, if x equal to 0, y equal to b to the power of 0. Okay, in mathematics, for any number, when any number with the power of n, the value is equal to 0 for that function. But in this case, this point is belong to x and y actually. Okay, based on the exponential function, y equal to -3. Sorry, this just for this, for example, not negatively. Okay, in this case, for any value of x and y, at this point, y equal to 0, x equal to 0, y equal to 1. This 0.0 and 1 coordinate point is very important because that point show the point where the exponential function intersect the y-axis. Okay, so these are um, the properties of the property number 3. The graph of fx be as a y-intercept 0, 1 for the whole uh, uh, exponential function. It doesn't matter the value of b, but there is refer to the how is referred to the y-intercept x equal to 0, y equal to 1. Okay, then there is no x-intercept. Number 5, there is no x-intercept. The graph does never cross the x. When we draw this graph, here, this one. Okay, when we draw this graph, okay, at the tail area, the graph does not cross the y-axis or the q-axis. Never for exponential. That's the main characteristic we must know about the exponential function. Exponential function. The both side. The other one at the right hand side, the same cases here, the function does not cross the y-axis. Okay, now we are talking about the value of p, the base, the base of the exponent. Okay, if the value of b is greater than 1, if the value of b is greater than 1, what we can say here is the value of b is greater than 1. Value of b is greater than 1, like this. When b is positive, when b is greater than 1, not just positive, it's greater than 1. When b equal to 1.1, b equal to 2, 3, 4, 5, and so on, as long as it's greater than 1. Okay, what happened to the graph? When we draw this graph, we can have the graph is rises from the left to right. The graph is rise from the left to right. For example, maybe this is a y equal to 3x, y equal to 3 to the power of x. Any value is greater than 1. We will have a graph like the blue graph in figure 130. Okay, the second one, when b is between 0 and 1. The b is between 0 and 1. What happened to the graph? The graph will be like this. That is, the graph is we can say that the graph is approach the x axis. The graph is become to the graph is approach to the x axis. As x become more and more positive. When the value of x is the value of x is positive and so on, the graph will have as you can see, the graph might have a negative slope, but it depends on the value of b. Yeah. Now, for example, maybe it's 1 over 0.5 to the power of x. So we have these two graph for the exponent. Okay. Example 1.34. You can refer to example 1.34. I show you how to draw the graph based on the coordinate. We still need the coordinate point. The coordinate point for every point. And then this, for example, when q when q when y equal to 2x to y equal to 2 to the 2 with x power, uh, y equal to 2 to the power of x, or to the exponent of x, base b equal to 2, with base 2. And then when we draw this graph, I just plot this graph at any point on the graph that belong to the curve. Then when I just connect this point, we have this kind of graph. Okay, this is y equal to 2 with the x power, with the exponent power of x. The exponent of x. And then the exponential equation and exponential graph with b equal to 2, the base is 2 and the power is equal to x. Okay, the next example, when b is between 1 and 0. B is between 1 and 0. When b is, for example, b equal to 0.56. B is less than 1 but greater than 0. Okay, we can have a graph like this. The graph is, if you can see, the graph is fall from the left to right. When x increase, the graph is fall from uh, from the left to right. In other words, the graph, we can also say that the graph is approach the y-axis. The graph is approach the graph x-axis when the as x become more and more positive. When the value of x is bigger, so maybe the graph just approach the x-axis. The graph never in theory the graph is never touch or cross the coordinate point, for when you try to find the uh, the exponential. Okay, that's how to draw the graph. And then when we can there is another value for b. This another value for base. We call it the exponential with base, with the base e. E is equal to 2.7182181118, and so on. Okay, that's e. We have e is greater when e is greater than 1. E is greater than 1. The next case when e is greater than 0. For example, in this case, we have y equal to ex. This graph, the next graph is maybe y equal to 1 over e to the power of x. That's how to draw the exponential function. Okay. Now, you know what is a exponential function. So the next part is about the application, how to apply. Okay, how to apply uh, this concept, this exponential function in economy and business. Okay, for this case, I choose population growth. How to estimate the number of a population? Population growth refer to the situation, refer to the percentage change. Percentage. Normally, the percentage is calculated annually. The percentage change of the population level. So the population growth can be calculated by using the following formula P equal to P0 times 1 plus R to the power of T, where P is the population after the T-year period, population at the year T. P0 is number of population at, for example, is refer to the uh, okay, sorry, P is the number of population after T year. P0 is number of population in the beginning year. At the number of population in the beginning of the year. R is the population weight. R is equal to population growth rate. How much, how many, what happened to the population every year? How much does it does the formula the population increase or decrease? Normally in Malaysia, we calculate the number of people living in Malaysia annually. That's just the estimation, not the real answer. Okay, since we have this concept, this exponential concept, we can apply this concept in terms of the population growth, for example. Okay, in this case, I will just explain this part only 1.9, 1.9.1 about the population growth. The other part, after this part, the other example, for example, if you look at the 1.35 and 1.36, there's a few questions here. I hope I will leave it to you. I hope you can do your exercise, do your revision to make sure you understand this subtopic. But in this class, I will show the one example only when P equal to P0 times 1 plus R to the power of T. Okay, for example, let's look at into example 1.35. Okay, 1.35, let's say we have, for example, example 1.35, where P equal to P0, we know the formula is P equal to P0 times 1 plus R to the power of T. Okay, what given in the question is, if you look at the question, given in the question is, assume that the total population of country is 10,000, and with an annual growth rate of 2%. What is the total population of the country X after 3 years from now? For example, let's today, our number of people is 10,000. But we have the information that every year the total information will go as much as 2%, as 2%. The question is, what is the total population of country X 3 years from now? 3 years from now, T equal to 3. So since the origin, the first value, the origin value of quantity is 10,000. Then we just apply the formula 1 plus R. 1 plus R. R is growth rate, number of G is population growth rate. In this case, we assume that the population is grow by 2% per year. So we know that now that the what is this the initial investment, initial population is 1,000. The annual growth rate of population is 2%, given in the question. Okay, now we just find the value of P, that the total of population 3 years for now. So P equal to, the original is 10,000 times 1 plus 0.02 to the power of 2 to the power of 3. So that the answer is equal to 10,612 orang for Malaysian case lah. For Malaysian case, this is for uh, uh, how to find how to apply the concept of the concept of mathematics, especially in terms of the exponential. We can find for example, in this case, it's about the total population. Okay, again, this formula for total economic growth for the number of economic growth by using the concept of exponential. Okay, I think that's all for exponential function. That's just for the exponential. I hope you can do your exercise, do your homework, do your exercise. If you want me to check, just write your answer and share with me in PDF format, and then I will check for you. I hope you can do this thing. This thing is voluntary, but make sure you have good enough exercise. Do your revision before you enter to your exam, whether mid exam or final exam. Okay. Any questions so far? Any question? I hope everything is okay.
No question.
Okay. I think we take break for 10 minutes. Before after break, I will continue this topic. This subtopic 1.10 logarithm short function log function. Okay. Can we take break now? Are you okay? Okay. We take a break for 10 minutes. Okay, we will continue our lecture on 5. Now okay, now it's 3:55. We will continue at 4 at 10 past 4 for 10 minutes. Then after break, we will continue this topic. Right now we take a break for 10 minutes.